My dear students, in the previous video, I have solved some problems on the topic definite integrals. Now, in this video also, I am going to continue the problems in definite integrals, but by using the properties of definite integrals. We are going to evaluate the integral problems by using the properties of definite integrals. Properties of definite integrals. Properties of definite integrals. Okay. First, I am going to explain the properties one by one, and then we will solve the problems using the properties. First property, property 1. Integral a to b f of x dx. Integral a to b f of x dx is equal to integral a to b f of u du, where a less than b. B is the upper limit, a is the lower limit. That implies a less than b means a is lower limit, b is upper limit in the number line values. B is greater than a. So what this property shows, if integral a to b f of x dx is equal to integral a to b f of u du, if you change the variable, here x is the variable, here u is the variable. If you change the variable, the integral value is not affected. The definite integral is independent. It is independent by changing the variables. If you change the variables, the integral value is not changed. That is, this property states. That means x is changed by the variable u, but the limits are all same, and the value of the integral is also same. That is the first property. Second one, so by changing the variables, the definite integral will not affected. That is the first property. Second one, integral a to b f of x dx equal to minus integral b to a f of x dx. So in this property, if you interchange the limits, the sign of the integral is changed. Integral a to b f of x dx. If you change the limits from b to a, then sign of the integration is changed. So integral a to b f of x dx is equal to minus integral b to a f of x dx. If you change the limits, the sign of the integration is changed. That is the property 2. Next, property 3. Integral a to b f of x dx equal to integral a to c f of x dx plus integral c to b f of x dx, where a less than c less than b. So c lies between a and b. B is greater than c and c is greater than a, or a less than c less than b. So if integral limit a to b f of x dx, if you find one more value in between a and b, the limit of the integral is split into two integrals by introducing the limit c to b. Integral a to c f of x dx plus integral c to b f of x dx. So a to c plus c to b. The limit a to b is straight away by using c. We can split this into two integrals, integral a to c f of x dx plus integral c to b f of x dx. That is property 3. Next one, property 4. Integral a to b alpha into f of x plus beta into d of x dx. Integral a to b, some alpha into f of x plus some beta into d of x. Alpha and beta are constants. In this case, the constants are taking out of the integral. Alpha into integral a to b f of x dx plus beta into integral a to b g of x dx. So f of x is multiplied by a constant alpha and g of x, the function, is multiplied by a constant beta. This integral a to b alpha into f of x plus beta into g of x dx is split into two integrals by taking the constant alpha out of the integral and beta is also taken out of the integral. You will get alpha integral a to b f of x dx plus beta into integral a to b f of x dx, and alpha and beta are constants. This is property 4. The 4 properties are listed here, and then we will see the 5th property now. By using these properties, we are going to solve the problems in our exercise. Coming exercise, we have to use these properties to solve the problems. So deferred interval will not affect if the variables are changed. That is the first property. Second one is, if the limits are interchanged, the sign of the integral is changed. Third one is, integral a to b can be split into two integrals a to c, c to b. And fourth one is, the constants, if you multiply by the constants with a function, the constants are taken out of the integral. Next, property 5. Integral a to b f of x dx is equal to integral a to b f of a plus b minus x dx. See, integral a to b f of x dx, a function is integrating a function between the limit a and b. It is enough, we have to integrate that, replace the function variable x by the adding lower upper limit a plus b and subtract the variable x, is the same answer we get for both this integration. Integral a to b f of x dx can be expressed as integral a to b f of a plus b minus the variable x into dx. This is the property. Instead of finding integral a to b f of x dx, we are adding the limits lower and upper limit a plus b and subtract the variable, you integrate, you will get the answer. That is our property 5. Next, suppose in this property, if a equal to 0 and b equal to a, what do you get in this case? If it is the case, integral a to b f of x dx is equal to integral a is 0, b is a, integral 0 to a. If a is 0, b is a, integral 0 to a, f of a is 0, b is a minus x only, dA. The integral a to b becomes integral 0 to a, f of x dx becomes f of a minus x dx, because a is 0, b is a. That's all. Okay? Next, property 6. If integral 0 to 2a, integral 0 to 2a f of x dx, integral 0 to 2a f of x dx is equal to integral, you can write it as integral 0, instead of 0 to a, I am writing integral 0 to a only, f of x plus f of 2a minus x dx. The function is split into two functions, f of x plus f of 2a minus x. 2a minus the variable x is intermediate. So instead of integral 0 to a, it is enough to find integral 0 to a, f of x plus f of 2a minus x dx. The variable x can be replaced by f of 2a minus x. It is one integral and f of x is another integral. Adding like these two functions, you will get the same answer for 0 to 2a f of x dx. This is your property 6. 7th one. If f of x is an even function, if f of x is an even function. If f of x is an even function, integral minus a to plus a f of x dx is equal to two times of integral 0 to a f of x dx. If the function even function f of x is an even function, it is integral minus a to plus a f of x dx can be expressed as two times of 0 to f of x dx. See, if f of x is an even function. When will you say that the function f of x is an even function? If a function f of minus x equal to f of x. If f of minus x equal to f of x, if you replace by x by minus x, it is same as f of x. If f of minus x is equal to f of x, then we say that f of x is an even function. This is the definition for even function. If f of x equal to f of minus x equal to f of x, then f of x is an even function. If it is an even function, integral minus a to plus a f of x dx is two times of 0 to f of x dx. Suppose if f of x is an odd function, that is property 8. Property 8, if f of x is an odd function, if f of x is an odd function, then integral minus a to plus a f of x dx is 0. The integral value is 0 if f of x is an odd function. When will you say that the function f of x is an odd? If f of minus x equal to minus f of x. If f of minus x equal to minus f of x, then f of x is an odd function. Okay. F of x is an odd function. Example of even function. Cos of minus x equal to cos x. Cos of minus x equal to cos x. Therefore, cos x is an even function. Therefore, cos x is an even function. Okay. Sin of minus x equal to minus sin x. In this case, f of minus x equal to minus f of x. In this case, sin of minus x equal to minus sin x. Therefore, sin x is an odd function. Sin x is an odd function. So, example of even is cos x. Example of odd function is sin x. Similarly, x cube is an odd function. X cube is an odd function. X squared is an even function. Because x of minus x whole cube is, what is it? Minus x whole cube is minus x cube. Therefore, x cube is an odd function. Minus x squared is x squared. Therefore, x squared is an even function. This is odd function, this is even function. These are the examples of odd and even. If it is even, in minus a to plus a f of x dx is 2 times of integral 0 to f of x dx. If the function is odd, minus a to plus a f of x dx is equal to 0. That is our property 8. Okay. Next. Ninth one. Ninth one. If f of 2a minus x equal to f of x. If f of 2a minus x equal to f of x, then integral 0 to 2a. Integral 0 to 2a f of x dx equal to 2 times of integral 0 to a f of x dx. It is one property. If f of 2a minus x equal to f of x, then integral 0 to 2a f of x is 2 times of integral 0 to a f of x dx. Okay, this is property 9, and next one, 10th one. If f of 2a minus x equal to minus f of x, if f of 2a minus x equal to minus f of x, then the integral 0 to 2a f of x dx equal to 0. Okay? If f of minus 2x equal to f of 2a minus x equal to minus f of x, then integral 0 to 2a then 0 to a f of x dx is 0. If f of 2a minus x is my f of x, then integral 0 to a f of x dx is 2 times of integral 0 to a f of x dx. This is 10th one. Finally, last property. Eleventh one. Integral 0 to a integral 0 to a x into f of x dx. Integral 0 to a x into f of x dx equal to a by 2 into integral 0 to a by 2 into 0 to a f of x dx. Integral 0 to a x into f of x dx is equal to a by 2 into integral 0 to a f of x dx. It's one property. It is possible if f of a minus x equal to f of x. If f of a minus x equal to f of x, then this integration is true. If f of a minus x equal to f of x, this condition satisfies, this integral is true. That's all about the properties. We will solve some problems using these 11 properties one by one. Okay? I am going to solve one problem using these properties now. Listen. It is given in your textbook. The problem is using these all properties, you are going to solve the problems in your textbook. Evaluate the following problems of integration using the property of integral. Properties of integrals. Evaluate the problems using the properties of integrals. That's our question. Evaluate using the properties of integral. Problem. Evaluate integral minus 5 to plus 5 x into cos x cos of e power x minus 1 by e power x plus 1 dx. See, you have to evaluate this integral using our property. You consider the function f of x is equal to x cos of e power x minus 1 by e power x plus 1. This is f of x. What is f of minus x? This is minus x into cos of x. In the place of x, you have to put minus cos of x e power minus x minus 1 by e power minus x plus 1. So that is minus x cos of e power minus x is 1 by e power x minus 1. By e power minus x is 1 by e power x plus 1. You can write it. Again, this is minus x cos of, taking LCM, e power x, 1 minus e power x, 1 minus e power x by, again 1 plus e power x. Taking LCM as e power x, e power 1 minus e power x by e power x, 1 plus e power x by e power x, e power x cancelled, denominator was cancelled. Again, I am going to take cos of This from this problem, x into cos of, I am taking minus here out in the numerator. I get e power x minus 1 by, if I take minus out, I get only, is it not in the denominator? You take the minus sign in the numerator only, it becomes e power x minus 1 minus e power x becomes e power x minus 1, and 1 plus e power x as it is, you can write it as e power x plus 1. Okay, this is e power x plus 1. This minus, cos of minus is cos, no. So f of minus x equal to minus x into cos of minus theta. This is cos of minus e power x by e power x plus 1. Cos of, this is cos of minus of e power x minus 1 by e power x plus 1. You can write it. Cos of minus theta is cos theta, you know, therefore minus x into cos of minus theta is cos theta, e power x minus 1 by e power x plus 1. So this is minus x cos of e power x minus 1 by e power x plus 1 is minus x into cos of e power x minus 1 by e power x plus 1. You will get, therefore this is minus f of x. So f of minus x is minus f of x we derived. Therefore the function f of x is an odd function. Therefore f of x is an odd function. For odd function, integral minus 5 to plus 5 f of x dx equal to, f of x is the given, integral minus 5 to plus 5, f of x is x cos of e power x plus 1 by, minus 1, e power x minus 1 by e power x plus 1 dx equal to, since it is not, f of minus x equal to minus f of x, then f of x is an odd function, therefore odd function gives the value 0. Integral minus a to plus a f of x dx is 0. Therefore the value of this integration is 0. Without actual integration, actually we are not finding the integral value of the function, but by the property, the given function is an odd function we derive, therefore the integral value is 0 we get. That's all about the problem. Okay, like that, we are going to solve the remaining problems using our properties. We will see one by one. Thank you.